Today will be an explanation of what is Euler's number, or more commonly known as E. Only 34% of people who watch my videos are subscribed, so if you like the video, make sure to hit that like and subscribe button. It's free. Euler's number, denoted as E, is named after the Swiss mathematician Leonhard Euler. This is kind of interesting that it is named after Euler when the number was really first discovered by John Napier in 1618 and properly introduced by Jacob Bernoulli in 1683. Well, to understand why E is named after Euler, we first must understand where it comes from. E, or Euler's number, is equal to 2.71 blah blah blah. It's also equal to the limit as n approaches infinity of 1 plus 1 over n to the power of n, or the power series, or I guess the summation of 1 over n factorial, which this equals 1 plus 1 over 1 plus 1 over 1 times 2, and so on and so forth. So its origin really came from this formula here when studying compound interest formulas, where n is equivalent to the number of intervals in a year in which the compound interest is evaluated. When compound interest is calculated, it is better to calculate the interest more often, even if it's in smaller amounts. Let's give an example. Let's say an account starts with $1 and pays 100% interest per year. Okay. Well, if this interest is only calculated once per year, then we'll have 1 times this 100% interest, which will yield $2. What about twice per year? So once every 6 months. Well, 2 per year well, this means that we'll first start off with $1 times 50% interest will be $1.50. But we're not done yet. Then our interest will be taken another 50% from this $1.50. Therefore, we will actually yield more money, equivalent to $2.25. So look, 25% more. No, 12% more than if we just calculated it one time per year. Well, what about 4 times a year? Well, this would be kind of our formula. 1 times 1.25 to the power 4, right? Because it's 1 and then this quarter because we're doing it quarterly. Well, this yields $2.44, even more than if we just did it 2 times per year. If we continue on and continue on, what if we calculate this interest an infinite amount of times per year? Okay, seems weird, but this is what's known as continuous compounding. So continuous compounding interest, given our previous conditions, will yield about $2.71 at the end of the year. Now, this might look familiar. This is just about what E is equal to. Now, why is this? Well, this happens because let's look at our formula. This is what is calculating our interest. I'll call it I. This n is the number of times per year that interest is calculated. Okay. So if we aren't calculating it that many times, say, let's start with 4. Well, look at this. Our exponent is very small. Our exponent is only 4. Even though that this fraction is larger, this exponent really, in the end, matters a lot more. Now, what if we'd say we're calculating it daily, which would make it (1 plus 1 over 365 to the power of 365. This power is humongous. It doesn't even matter what number is here. This is going to be larger in the end, right? Because our exponent is going to have much more weight on this end total. And that's where our limit notation comes from. The limit as n approaches infinity of 1 plus 1 over n to the power of n. As these two numbers approach infinity, even though this is technically going to 0, we're still having a very large exponent here, which is what yields our number of about 2.71. I'll say this is about estimate. Later, it was discovered by Euler that E is also equivalent to the infinite series of 1 over n factorial. This was proven via binomial theorem, which I will not get into in this video, but please leave a comment below if you'd like to see a video on binomial theorem. And this was really the reason that E was named after Euler, because of his more recent popularization of the constant and his proof with the infinite series. In summary, Euler's constant is found by examining the limits of compound interest and has been used in many applications all across mathematics, including exponential growth and decay, standard normal distribution, and natural logarithms. There's also a very popular equation, e to the I pi, which equals -1. Even though that technically all pi and e are irrational and I is imaginary, it equals -1. Just a very basic but negative number. Thank you so much for watching. If you enjoyed this video, make sure to hit that like and subscribe button and leave a comment below of what topic you'd like to see next. This is Dylan signing off. Hope you have a good day and see you in the next one.